I'm Dave Wells. I work as a research analyst with the Eckerson Group. Also work with TDWI as an educator and do some work as an independent consultant. I've worked with data for many, many years, started my career as a programmer in the late 60s. I've seen a lot of changes in the data world over those years, and I see even more interesting things to come in the future. One of the things I just completed with Eckerson Group was a research report on data lake management. This was an essential report to step up to this question of data lake, which has been kind of messy. So what we found was that people struggle with what is a data lake, how do I manage a data lake, how do I stay on top of the movement of data through this increasingly complex system of data stores and kinds of data and kinds of databases. So ultimately the finding was you can't do this without the right tools. It's a thing that simply can't be done manually. So a lot of our old data management practices don't work very well in a data lake world. We have seen a lot of changes in data recently with the influx of big data. The whole world of data has been shaken. I refer to it sometimes as the data quake. We spent many, many years that we felt we were on a stable foundation of data and everything was about relational database management systems and internal enterprise data. And then big data came along, NoSQL came along, graph databases came along, external data exceeded internal data in terms of the volume of data that we work with, and the whole world changed. And as it changed, we had some difficulty keeping pace with our data management practices. Early on, we talked about NoSQL with the idea that NoSQL meant we could work without a query language. We then discovered that that doesn't work and redefined NoSQL to stand for not only SQL. Okay. Clever use of words, but the reality is we recognize the need for a query language. Today there are probably somewhere in the neighborhood of 15 SQL on Hadoop kinds of tools out there. So some of the old things that we had, we still need. Some of the new things that we need are still evolving. Today we don't have a lot that works well with modeling of data in the data lake or modeling of unstructured data. There's an emerging technique called Common Concept and Object Modeling Notation by Ted Hills that begins to show us how we can model this data and some of the constructs in big data that don't fit into entity relationship models. So data modeling has to change. Data pipelines have to change. Our old model of data warehousing was a single direction data pipeline, pour data into a funnel and it comes out into the data warehouse. Now we have this omnidirectional data movement, data moving every which way, data constantly in motion. Trying to stay on top of those complex pipelines and manage the flow of data is a very, very difficult thing. I have this vision, in fact, I don't know how long it will take for it to become reality, but I have this vision of managing the movement of data in the data lake world, the big data ecosystem that's analogous with what's done in smart cities and traffic management. When there is a traffic disruption in a smart city and we have data and we have sensors and we have monitors, we know how to reroute traffic, how to adjust bus schedules, public transit schedules, so on and so forth, how to notify people and inform them of traffic disruptions. So if we could take the smart city analogy for traffic flow and apply it to data flow, we would substantially change the number of problems that we deal with in data lake management. Nearly everyone in business today is seeking data. Business analysts, data scientists, everyone needs data, they're looking for data sets, and the way they typically find data sets is word of mouth, tribal knowledge, working with data that they've previously worked with because they're familiar with it and they know it. And that's flawed because they don't find the best fit data sets. That's flawed because we find ourselves recreating similar data sets over and over again instead of reusing those that already exist. So we need to create a storefront, a digital marketplace like Amazon, where people seeking data can go search, browse, read descriptions, preview data, see 3, 4, 5-star ratings by other users of the data sets, find the data sets that they need, and click to acquire those data sets, assuming that there are no governance constraints and that they're authorized to access the data. This gives them a fast, easy way to find the right data and accelerates the process of analyzing data. They find it faster, they get the right data more quickly, improves the quality of analysis because they're working with the best fit data. In the next 1 to 3 years, I see many rapid changes in how we work with data. The influx of big data is going to continue. The Internet of Things is going to drive us to a tremendous volume of data, sensor data of all kinds, machine-generated data of all kinds. And we're going to have this rapid explosion in data, sometimes without a clear picture in advance of what we will do with that data. So we're going to be looking for opportunities to exploit new kinds of data that come to us. We're going to see different ways that we have to manage the data. The data lake concept has to sustain because that's the only way we're going to be able to capture this data prospectively, expecting that we'll find value from some of it later. That's going to increase the importance of data lake management tools, the data pipeline tools that help us manage the movement of data through this ecosystem. In the data space, I think we'll see the complexities of working with big data and with data lakes settle down as data lake management tools become mature, strong, and mainstream, so that the day-to-day handling of the data is less complex. Then we're going to have to step up to some of the human aspects of working with data. And by human aspects, I mean such things as governance. We talk about data governance, but the reality is we don't govern data, we govern what people do with data. And today we govern in some difficult ways that are about controls and gates. So the mechanism is, if you're not authorized to see a particular piece of data, there's a gateway that prevents you from seeing it. If you're supposed to work with data in a particular way, there are authorization and approval steps that you have to go through. In this world now of self-service, the old model of governance is bottleneck and bureaucracy, and we have to rethink governance. So instead of gates, or in addition to gates, not instead of gates, because we'll still need gates, but in addition to gates, we need guardrails to keep people on the right path in working with data. We need guides so they know what the expectations for working with data are. So if you begin with the guides and you understand the guides, you don't bounce off the guardrails. If you bounce off the guardrails, you don't run off the road. If you do still need guidance, then you encounter the locked gate. So we need a 3-tier approach to governance that includes guides first, guardrails second, and gates as a last resort. The other aspect of it is controls. Controls tend to be chain of command, top-down controls, and that worked in a hierarchical world. Now in a self-service world where we're managing data horizontally, controls are problematic. We will still need controls, but again, they should be a last resort just like gates. And we need to focus more on crowdsourcing, collaborative governance, coaching, and data curating. And if we can bring those things into our practices, then we'll create a culture and human processes that match the world that we have with self-service analytics and self-service data. In the world of analytics, we'll see some substantial growth there, driven by deep learning, driven by machine learning, driven by different kinds of data analysis. Today, the holy grail is predictive analytics. And predictive analytics is the pinnacle of what people aspire to with data analysis. In the research labs today is an entirely different concept called anticipatory analytics. And the difference is predictive analytics is looking at probability, what is likely to happen in the future. And predictive analysis tries to give you fairly reliable singular answers about what the future holds. Anticipatory analytics is about possibilities. So instead of trying to find a single answer, it's opening the eyes to all of the things that might be possible in the future. So predictive analytics can drive insight. Anticipatory analytics can drive innovation, because innovation is really about brainstorming and exploration and trying many things. Innovation is going to be the differentiator for the leading companies of the future. It is the companies that innovate that will be the leaders and that will shape the future.